get these for $109. These are Boom, I'm not sure how to pronounce them. These are Bluetooth noise canceling headphones. They're pretty good. The bass response is awesome. And I'll be doing more reviews on my main channel, Fixed Protocol. But anyway, we're here to talk about your code. Your code sucks. So the topic today is about splitting up your code because, well, let's first of all address why you need to split up your code. So if you are building a complex application and you're building it from one central code base, as you know, many new programmers will probably do when you first started writing your programs, you probably got in the habit of writing everything all in one, right? Because the first programs that you wrote were very simple, right? Very simple programs. There was no real need to, I look ridiculous with these things. There was no real need to break up your code, right? It's too simple for that. And then you started writing more programs and more programs and more programs. And they're all basic. You know, when you're a beginner, you're learning, you're doing basic programs, right? So they're all very short, very simple. No need to break it up. Problem is that the danger there is getting in a habit of always writing your code, you know, in a central code base, just a singular code base, right? And when you move from being a beginner to getting hired and you're working on big projects and you're working on complex applications with lots of lines of code and things like that, what you're going to run into, what you need to be aware of as a beginner, is you're going to run into the risks that come from having just one central code base. So one of those risks are, let's say you write a program that it has 4 components, right? You have one component that does some kind of mathematical function, another one that does some kind of graphical function. You have another one that does some kind of predictive algorithmic function, and you have another one that does some kind of performance analysis function, right? What happens when you need to do an update to the graphics component of your code, right? We're talking about larger programs. And again, I got to stress larger programs. If it's a smaller program, it's much easier to handle stuff like this. But when you have a larger program, we make a change to the graphic component of the software, that can actually break other parts of the program. So there may be a dependency that we weren't aware of. So you made an update to the graphics component, not realizing, you had never thought that the mathematical component was relevant, right? Somehow you missed that there was a dependency. Somehow the graphical component somewhere in the code pulls a variable from the mathematical part of your program and uses that for some function. It may not even be a standard function, right? So you could actually make the change, cause the break, and not realize that there's actually a break until that rare part of the code is triggered. Like maybe the problem is only when you're doing option 12, whatever option 12 is in your application, does it use that part of the code that relies on a variable from another part of the code, right? So this could actually get missed. So you make an update to the graphics component, everything seems to be fine, and then weeks down the line there's some kind of crash or problem. What's happening? Investigate, then you find out, oh guys, when you made that change to the graphics component, there's actually a dependency in the mathematics part of the code. So we need to actually update that part as well. We missed it. So here is the solution. When your application gets beyond a certain size, and that's for you to figure out and determine, like what size do you need to start breaking things up, you need to break things up. So therefore you have a separate code base for graphics, separate code base for math, separate code base for performance analysis, right? So therefore, if you need to update the graphics components, you can do that and not worry about breaking the other parts of the code, because everything is sort of self-contained. There's no sort of dependency from the other parts of the code. And I'm speaking very, very simplistically. I mean, there's obviously more to it than that, but that is definitely something you need to consider. You know, whenever you have a large program and you have everything all in one, any changes at all whatsoever to that code can affect other parts of that code. So one reason to split it up. Also from a support and maintenance standpoint, if everything is in one, then potentially a failure in one part of your code, let's say there's a failure in the graphics part of your code, can break everything. And the only way to fix that is to restart everything, because there's only one thing, right? I think potentially a good example, this might not be a good example. Well, think about an application that has several, like something that is built in a way where anything that gets stuck, your only solution is to restart the entire thing. There's no way to restart that one thing. Like, for example, if you break up the application, the theoretical application that I talked about, you know, graphics component fails, you can just restart that, right? Restart the graphics process, right? Problem with the mathematical function, you can, if it gets stuck, you can restart that, right? You don't have to restart everything, because let's say there's certain information, there's something happening in another part of the program that you don't want to lose, right? So, you know, the user is using your application and they may have entered, you know, some information or whatever it is, they're doing something and they don't want to restart the whole thing because they're in the middle of something. It's just one piece that's broken, right? So if you could have broken it up into a separate process, then that could have, you know, been dealt with in a better manner. And I think to further clarify what I'm talking about, I'm really talking about a complex system. I know a lot of you probably develop applications that are really more singular, sort of a front-end application that's really, you just have this singular GUI that does certain things, and we crashed. When you're talking about something like, say, a trading system, right? You really wouldn't want to have everything all in one. You would want to break things up. Maybe there's an order entry system. That's where you enter your orders. Maybe you have a smart order routing component. So that's where orders were created in the order management system, and that generates some data that gets sent to your order routing system, which takes that data, processes it, does its magic, and then routes it to another system. So if there's a problem with the smart order routing part of your trading system or trading platform, if everything was in one, you'd have to restart everything. So a trader's in the middle of trading, he's got to restart his application just to fix that problem with the market data or order routing. Makes no sense. It's very bad design. So what you want to do is you want to have order management system separate from your order routing system. So therefore, order routing system gets broken. So someone sends an order out, it gets stuck, it doesn't get routed properly because order routing system is broken. You can simply restart the order routing system. While that's happening, the trader can still access the front end and they can enter new orders. They can see what the status of their orders are, all independent of this order routing system being broken. Obviously, no orders that rely on the order routing system to be routed, because maybe some get routed in other ways, No orders can get routed through that system while it's broken, but that is an isolated issue, right? Other things can still work. Other parts of your program can still work while this thing is stuck. And from a troubleshooting standpoint, we can monitor, address, restart, shut down this separate component, as opposed to, again, bringing down the entire system. So the moral of the story is split up your code. Otherwise, you're going to pay the consequences of the risks involved in having everything all in one when you make code changes affecting and breaking potentially, any and everything. And then you also have the issue of the support, like we just talked about, where it's better to have everything compartmentalized so that I can, or modular if you want to say, where I can shut down, track, monitor, and maintain different parts of this system, that was previously referred to as an application, but now I'm gonna call it a system, because it's actually, we're talking about the model of, instead of building something as a singular application, build it as a series of applications. You break out different functions of your program into their own sort of programs, right? So you have one program that does the math, one program that does the graphics, one program that does some other processing, right? And that makes everything much more robust, easier to maintain, easier to support, and it just makes much more sense. Anyway, this is the Computer Programming University. Thank you for listening in and clicking on that like button. Definitely appreciate that. Shout out to my CPU squad. You guys rock. And getting back into it, slowly but surely, getting back into it. I would like to ask any of my subscribers, if you are a subscriber already, unsubscribe from my channel, please. And then click on subscribe again, click on the bell. There's a problem with YouTube right now where if you don't do that, you will not get notified when I post new videos. So if you enjoy the content and you don't want to miss out, you're going to want to do this, because there is a problem that needs to be addressed with YouTube, because, whatever, their code sucks, right? So again, everyone who subscribed, unsubscribe, subscribe again, and then click on the bell icon to get notifications. If you don't click on the bell, you're not going to see anything, right? So you might as well unsubscribe and stay unsubscribed. Anyway, this is Computer Programming University, and we are back at it again. See you guys soon. Split up your code. Split up your code. You didn't know I could sing, did you? Split up your code. Split up your code. Peace out.